All right, I'm going to go over this review sheet here, and I'm going to try and go quickly, so feel free to pause to catch up or, I don't know, rewatch something if I go too fast. All right, so for these graphing problems here, my first job is to try and factor the top and the bottom so that I can see if anything cancels out. So the top and the bottom do factor in this case. The top is 2x minus 3 and x minus 2. And the bottom, the denominator, is x plus 3 and x minus 2. So I do see I have a cancellation. So I have a cancellation at x equals 2, so I'm going to have a hole. So that hole begins at 2, and then what? So what I do to figure out the hole is what I have left over is 2x minus 3 over x plus 3. So this equation does not know that there was a hole at 2. So if it could, when you plug in 2, you get 4 minus 3, you get 1 on top, and the bottom you get 5. So it would go to 1/5 if it could, but the other part created a hole. So at 2 and then 1/5, there's your hole right there. And I would put that a little lower, but this pen. All right, so my domain. My domain is all real numbers, but x cannot be -3 or 2 still. Vertical asymptote, the only one left is -3. All right, and then you have a horizontal asymptote because of these guys right there of y equals 2. So that means you do not have a slant asymptote. X-intercepts and y-intercepts. The easiest one is the y-intercept because you let all the x's be 0. So all these pieces would disappear because they all have x. So I'd get 6 over -6, so that's -1. So 0, -1. The x-intercepts are a little bit more annoying because you have to make the top of the fraction equal 0. So when does the top of the fraction equal 0? Well, it's easy to look right here, the top of the fraction, because you want the y value to be 0. So that only happens when the numerator is 0. All right, so let's see. So 2x minus 3 equals 0 at 3/2. So I get 3/2 for my x value and 0 for my y. So 3/2 and 0. And remember, this guy cancels, so you don't got to worry about him. Otherwise, there would be 2 x-intercepts. All right, so we're on to graph 0, -1. And I got 3/2 and 0, so 1.5 and 0. All right, then I'm going to do my asymptotes. So x equals -3. Y equals 2. All right, and so the rest of this is just, you should confirm this on your graph. Oops, crap, what did I do? Oh, I went to the next page, sorry. All right, so confirm this on your graph. I already have mine typed in there. So I already have it in y equals there, and I would always graph the original because in case you made a mistake with, factoring or something, you would maybe recognize that. So I have it in y1. So hang on my graph. Do zoom 6 there. I fixed it. All right, so the rest of it you can see it's going through the x-intercepts. It looks like it has the right asymptotes. So I'm just going to draw that in. So it's coming up through here, skipping my hole there, and then it's over here. So if you need some points, you can look at the table. All right, for the second one down below. Now the second one, I need to try to factor the top to see if that does factor. But when you try it out, let's see, 2x and x, only options for 4 are 4 and 1 and 2 and 2. I can't use a 2 and 2 because I can't put the 2 in the back right there. And so I'm going to just try 4 and 1. So that makes 8 and 1, which doesn't make 5. So this does not factor. So I don't have to worry about it for now, but we will need it for our x-intercept. All right, so let's do the easy part, the domain. X can't be 2. So all real numbers, x cannot be 2. Vertical asymptote is also at 2. Horizontal asymptote, well, the top has a higher degree than the bottom. So there's no horizontal asymptote, therefore there's a slant asymptote. So I need to go and do long division. So x minus 2, put that into, let's see, 2x squared plus minus 5x plus 4. All right, so x to 2x squared, I need a 2x. So it becomes 2x squared minus 4x. Let's subtract, I get -x plus 4. So I need a -1 to make that. And I'm pretty much done, but I'll finish it off. You get a -x plus 2, and so you get a remainder of 2, but that doesn't matter. There was your slant asymptote. So y equals 2x minus 1. So we're going to graph that later. So it means I have no holes because it doesn't factor, nothing cancels. The y-intercept is when x equals 0. So if this is gone, this is gone, this is gone, I have -2. So 0, -2. So my x-intercept. All right, so the x-intercept occurs when the numerator is 0, because it's when the y value equals, I'm sorry, when the when the y value equals 0, that's when the numerator is 0. So since it didn't factor, I'll do the quadratic formula real quick. So that would get me 5 plus or minus, because I'm trying to see the zeros of the top. The square root here, the bottom is 2 times 2, so 4. So when you do the discriminant, you end up getting -7. So since you get a negative, you know there are no places where the numerator equals 0. So it means there are no x-intercepts. So fine. So when we graph it, that should confirm it. All right, so let's see. My asymptote is at 2. I have a slant asymptote at 2x minus 1. So let me put that at -1, go up 2 over 1 to graph this. All right, so remember the slant asymptote is what you're approaching as you go off to infinity. All right, and I have 0, -2. I think that's all I can say. All right, so I'm going to go to my calculator. All right, so I did put this in here. I'll just get rid of that first one and go down. I need to turn this one on. So there it is. All right, so there you can see it's going along the slant asymptote, and I see my vertical asymptote, so I'm just going to draw those in. So it's going along this asymptote, curling around, and this guy is just up here. And this is going more straight than not that curve. All right, so there we go. All right, up here, I need to solve this. This is just your basic cross multiplying. All right, so I have x times x plus 2, so I get x squared plus 2x, and then 32 minus 2x. So I have x squared plus 4x minus 32 equals 0. So this does factor into x plus 8 and x minus 4. So my two answers are -8 and 4, and both of those are fine. They're not domain issues. All right, this inequality over here, remember I have to make a sign chart, but first I got to move everything to one side so I can factor it. So I have 3x squared plus 5x minus 12 greater than or equal to 0. So when I factor that, I got 3x and x. I'm going to try 4 and 3. Let me see. No. Yes. Okay, so 4 and 3 here. So that gives me 9 and 4, which can make 5. So +9 minus 4. There we go. So for my sign chart, I need to do -3 and also 4/3. So if you try something behind -3, like -10, both of your items, both of your factors turn negative, so you get a positive. If you try something like 0 in the center, there's one positive and one negative factor, so you get negative. If you try something like 12 or something, you get two positives, so positive. All right, sorry, I have to keep stopping because people come in the room. All right, so I'm looking for this. I'm looking for when this graph is greater than or equal to 0, or when this function is greater than or equal to 0. Okay. All right, so I'm looking for these positive areas. I got this one, and it says equal to 0, so I also do want these numbers. All right, those critical numbers there. So I want -infinity to -3 bracket, or I will accept an area anything from 4/3 to infinity. That will make my inequality true. All right, down here it says I have a 6th degree polynomial with all real zeros. So I'm trying to tell you that there are 6 factors here, and you can see them all. So I see 1, 2, 3 crossing places. So I'm going to set up 3 parentheses. I see one pass through over there at 4. So I'm just going to put x minus 4 there. I see a bounce at 1. So x minus 1, and then -2, x plus 2. So the bounce is probably worth about 2. It's kind of a quick bounce. The -2 is like a slow pass through, so I'll put 3. Let's just make sure. 3 plus 2 plus this is a 1 right here adds up to 6. So we're all set. All right, number 6 and 7. Number 6, these are both inequalities. So remember, you have to pull everything over to one side, and you're going to kind of treat it like this guy up here. You're going to find the critical numbers and then do a test intervals. So when I pull, I'm going to leave my 2x over x minus 4, and I'm going to pull over the other guy, x plus 1 and 2x plus 5, greater than 0. All right, so I got to get a common denominator. Everything has to be compact so I can see all the critical numbers. So to get a common denominator, 2x is going to have to get 2x plus 5 minus the x plus 1 is going to have to get x minus 4. All right, and then on the bottom I have x minus 4 and 2x plus 5. All right, so I went and figured out the top part, or the numerator, you know, if you FOIL everything out and clean it up, you end up getting 3x squared plus 13x plus 4. And the numerator is still x minus 4 and 2x plus 5. All right, so I can see two of my critical numbers are 4 and negative 5 halves. But this guy up here, he's going to factor into 3x plus 1 and x plus 4. All right, now remember, when I do my critical numbers, I want to have areas that are greater than 0. So let me see, I'm going to draw that up here. So I have 4 critical numbers. I have 4, negative 5 over 2, and anything that makes the top 0 is possibly a place where things change. So negative 1/3 and also negative 4. So put those in order. So if I order those numbers there, negative 4 is the smallest and negative 5 halves. And then negative 1/3 and 4. All right, so it's going to be a little bit more annoying to keep track of what's positive and negative, so you might want to, you know, jot a little something down. So if you pick something like negative 10, all right, negative 10 would make this negative, that negative, that negative, and that negative. So you got 4 negatives, so that's a positive. And then you have something between negative 5 halves and negative 4. So how about like negative 3? So negative 3 would make this guy negative. Negative 3 would make this one negative, and also this one. So I have 3 out of 4 being negative, so that would still be a negative. All right, and so then I have something between negative 5 halves and negative 1/3. So how about negative 1? Negative 1 would make this guy negative. No, and negative 1 over here, yes, negative, and negative 1 here, nope. So I only got 2 negatives, so that's a positive. All right, and then negative between negative 1/3 and 4, I have a 0 would be easy. So let's see. The only thing 0 would do is make this one negative. So that means my answer would be a negative. And then pick something bigger than 4, and everything would turn positive. All right, so we are interested in areas that are greater than 0, not equal to 0. So remember that 4 and negative 5 halves, you can never say that you want those numbers because they make the denominator 0. They're actually illegal choices. But I want areas that make everything greater than 0. So I want everything behind negative 4. So I want everything, I'm going to list it down here, negative infinity to negative 4. Don't include negative 4. And I want everything between 5 halves and the 1/3, the negative 5 halves and negative 1/3, but I don't want to include negative 5 halves, so I want from negative 5 halves to negative 1/3. Do include the 1/3. Oh, I'm sorry, don't include the 1/3 because this is not equal to 0 either. If it was equal to 0, I would put a bracket. All right, and then I want everything past 4, so from 4 to infinity. So the only things that could ever get brackets here are, oh, my bad. The only thing that could ever get brackets, this little x up here should have been on the negative 4, the positive 4, not the negative 4. So anyway. All right, so I should have said you can never have positive 4 and you could never have this guy here. So anyway, so you can never have brackets around those numbers because you would never actually want them because they make the denominator 0. All right, for number 7. So 7 is a little easier because we're going to pull over the 2. So 4x over x plus 3 minus 2. Now that 2 is going to get a denominator of x plus 3. So I can give the top x plus 3. So I got a common denominator of x plus 3. When you simplify the top, you get 2x minus 6. And you have less than or equal to 0. All right, so I have 2 critical numbers. One of them is negative 3 and one of them is positive 3 for the top. So I get negative 3 and positive 3. So you do your test intervals like you did on the other problem, and you get plus minus plus. So remember, negative 3 will never be a valid choice because it makes the denominator 0. That's out of the domain. So my answer area here is my negative area. So I will say from negative 3 to positive 3. This does have an equal bar, so I would say I could equal positive 3, but I never want to be negative 3. So that's my answer choice. All right. So in this number 8, I need to multiply this out. So remember telling you one of the imaginary roots is like a trick because you need to make another one. So I have x minus 2 plus 3i, and then x minus 2 minus 3i. And then I have the 1/2, so that's 2x minus 1. And then I have the negative 1, so that's x plus 1. So my recommendation is to kind of do this in parts. You're going to multiply this together, and then multiply their answers. So the back side here is 2x squared plus x minus 1. And then over here, I'm going to get x squared. Remember, that's x squared. This is going to get me a negative 2x. This is also going to get me a negative 2x, so negative 4x. Everything else will cancel. And then the back part is going to be a plus, and the 2 plus 3i times 2 minus 3i is going to be 4 plus 9, so 13. All right. So you multiply this out, you get, let's see, 9 things. And so when you simplify them all down, you get 2x to the 4th minus 7x to the 3rd plus 21x squared plus 17x minus 13. So you are to multiply that out. I'm just trying to show you what the answer is here. So just copy my answer and skip the in-between step. All right, on to the last page. So here I'm finding all the zeros. I'm not going to use my calculator at all. Get it? No calculator at all is necessary on this problem. So I got my possibilities. Factors of 4. So that's 4 and 2 and 1, plus or minus all of them. And the factors of 2 are 2 and 1. All right, so the combinations, those fractions combined are all my factors, possible rational factors. So I need to get 2 of them out of here so that I can do something with a quadratic. So let's see, I've already worked this out, but I did try, had a couple mess ups, but I finally got 1 to work. So 1, so I get 2, negative 1, 7, negative 4, and negative 4. Nothing is skipped. All right, so I got 0 there. 1 times 0 is 0. Add up, negative 1. Get negative 1, get 6. Multiply, get 6 again. Get 2, and then get... Oh, hang on, something went wrong. Negative 1, 6, 6 times 1 is 6, 2. 2 times 1. What did I do wrong? Let's see. Oh, I'm so sorry. I'm sure you noticed this earlier. Why did I put 0 here? So that caused me all kinds of problems. Going too fast. All right, so 2. 2 times 1 is 2. Then I have a 1. 1 times 1 is 1, so I get 8. And I get 8 here, and 4, so 0. Yay. All right, and then I also, after some trial and error, I got negative 1/2 to work. Okay. So you just try a few, use a pencil, erase it if it's not going right. And so these are all positive, 2, 1, 8, 4. So I could kind of tell I needed a negative. So anyway, 2. Half of 2 is 1, so it's negative 1. Put a 0. Then get 0 again, 8. And finally I get negative 4. So again, yay. All right, so we have just figured out that x minus 1 is a factor and 2x plus 1. Which also means that 1 is a 0 and negative 1/2 was a 0. So I get 2 more. Well, what I have left here is 2x squared plus 8. So 2x squared plus 8 has to equal 0. So x squared has to be negative 4. So x equals plus or minus 2i when I take the square root of both sides. So I got plus or minus 2i. So that's an easy one, x minus 2i and x plus 2i. All right, we do the same thing down below here, but I did give you a clue. Use the fact that x squared minus 6 is a factor. Again, I'm going to do this without a calculator. You should be prepared for that. So x squared minus 6 must divide into this perfectly. So I'm going to do x squared minus 6 divided into x to the 4th minus 2x to the 3rd minus 3x squared plus 12x minus 18. All right, and so let's see, x squared to make x to the 4th, I need an x squared. So I multiply it, I get x squared minus 6x squared, so that goes under here. So you notice this is missing a part, so I'm going to have a hole in my problem here, but that's fine. Subtract, these go away. Negative 2x to the 3rd minus nothing is negative 2x to the 3rd, and negative 3x squared minus a minus 6 is positive 3x squared. Bring down my 12x. All right, to make x squared be negative 2x to the 3rd, I need a negative 2x. So that gives me negative 2x to the 3rd plus, whoopsie, plus 12x. I need All right, so subtract. This cancels and this cancels, but that's fine. So I'm bringing down 3x squared, and I have a minus 18. Well, that's good that this is skipping one because so does my x squared minus 6. So to make x squared into 3x squared, I get positive 3. So I'll multiply that, I get 3x squared minus 18. So perfect. Subtract, they both go away. Remainder 0 like it's supposed to be. All right, so what I now know is that this problem up here factors into x squared minus 6 and also x squared minus 2x plus 3. Now, x squared minus 6, I can figure that out real quick. I would get x squared minus 6 equals 0. So I would get 6, so I get x equals plus or minus radical 6. So those are ready to go. Now, and I got plus or minus radical 6. The other two answers are coming from this guy. So you're trying to factor it because you're like, oh, 3 and 1, they make 2. But if to make negative 2, you'd need negative 3 and plus 1, and now you lost your positive 3, so it does not factor. So good old quadratic formula. So your calculator, frankly, would not have helped you anyway here. All right, so quadratic formula, 2 plus or minus, you calculate your discriminant, and look at my handy dandy answer sheet, you will get negative 8 over 2. So 8, of course, reduces to 2 radical 2, so I got 2 plus or minus 2i radical 2 over 2. So all these 2's out in front here, those all disappear to 1's. So my last two zeros are 1 plus or minus I radical 2. So when you write those, you'd write x minus 1 plus I radical 2, and then x minus 1 minus I radical 2. All right, I would have written them on the line, but it's too fat and big. All right, so 11 and 12, last home stretch here. So let's see. All right, so solving this equation, the best way to do this, I mean, you could put the left side together and then cross multiply, but one of the ways we talked about in class is you can multiply by x and x plus 2. That's your common denominator. So when I do that here, the x plus 2's go away, so I have 6x times x, 6x squared. The center, when I do here, the x's go away, so I have 4 times x plus 2. I'd be careful. If this was negative, I would be extra careful, but it's not. All right, and on the 5, nothing cancels, so 5x and x plus 2. All right, so you got a nice quadratic you got to solve. So you got 6x squared plus 4x plus 8, and you got 5x squared plus 10x. All right, so pull everything to the left. You got x squared minus 6x plus 8 equals 0. Let's see. So I got x minus 4 and x minus 2 because that makes 6 also. So my answers are 2 and 4. And I look back, 2 and 4 are perfectly fine. They were not domain problems, so that's it. All right, for number 12, I'm going to pull that 1 over here. So when I square both sides, it'll be easier. So 4x plus 5 equals 4x minus 1. So I'm going to square both sides so that way I can get rid of this radical. So 4x plus 5. Remember, when you square both sides, you might be messing up one of your answers, so you got to check it. Over here, I got 16x squared. 4 times 1 times 2, so I get negative 8 in the middle, 8x, and then plus 1 on the end. So I'm going to pull everything over to the right. 16x squared, this will be minus 12x, everything's together, and then, let's see, minus 4. Now all of these divide by 4, so I'm going to do that. It doesn't change your answer. You don't even have to pull it out to the front, you just divide everything by 4. So you get 4x squared minus 3x minus 1. All right, let's see if we can factor this. So 4x squared might be 2x and 2x, and then I'd have to put 1's here. So when I do that, though, I don't get my 3x in the middle, so that's not it. So 4x and x is my other option. These have to be 1's. So I can get 3x here. If I do my 4x being negative and my 1 being positive, that gets me negative 3x. All right, so here's my answers. Negative 1/4 and positive 1. I look back, if I put 1 in here, everything works out. But if you put negative 1/4 in for x, you do not get equal answers. So I will not accept that answer. So the only answer is x equals 1. All right, we'll see you in class. Bye-bye.